everyone, and welcome to this episode of Boss Level, where we help to demystify and simplify the AWS technologies and services that you can use to build, run, and grow your games. My name is Chris Melissinos, and I'm the Principal Evangelist for Video Games and Immersive Technologies at AWS. And on today's episode, we will be discussing how developers can manage the cost of a full game lifecycle by utilizing containers. And joining me today are four awesome AWS Senior Solutions Architects. Please introduce yourselves.
Yeah, thank you, Chris. I'm super excited to be back here. I think this is my third Boss Level podcast.
Yeah.
So my name is Gena Gizzi. I am a Senior Games Solutions Architect. I've been at AWS for a little over 6 years, been working with games customers for about 4. So excited for the conversation today.
And we're excited to have you back. And next.
Hi, everyone. My name's Dominic Mills. Maybe you're getting tired of my voice and my face already.
Never.
Well, I am a Senior Solutions Architect here at AWS with a focus on games, of course, because that's what we're here to talk about. And I'm really excited to talk about containers today. I brought in my favorite container, so we will get to show that off later on in the show.
Okay, shoot. Now I'm going to have to find a prop around this video here, right? Of course. And next.
Hey everyone, my name's Adam Hatfield. I'm a Senior Solutions Architect here at AWS on the games team. Just like Gena, I've been here for a little over 6 years, and I'm super excited to talk about how we can use containers in the game lifecycle.
Excellent. And last but not least.
Hello, everyone. I'm Serge Poueme. I'm a solutions architect at AWS as well for the games team. I've been in the team for, it's been 4 years in total, I would say. Since I joined AWS, I've been 3 years with the team, working with a lot of different customers, actually working almost with everyone here on the call, also on some interesting topics. So I'm happy to be here and share some passion about containers and Kubernetes in general to the audience.
Awesome. And I'm excited to have you all here to join us as well and guide us and our audience through how they really can leverage containers to help manage, again, those costs during a full game development life cycle. But before we jump into all of that, we're going to kick it off like we always do. Let's talk about what you've been playing. So, Gena, back to you.
I have been absolutely obsessed with Bloons Tower Defense 6.
Nice.
It's living on my mind rent free. Like I can't stop thinking about that game.
Very cool. Dominic, how about you?
Yeah. So I am I'm a new puppy parent, actually, as of a couple of weeks back.
Hey.
So it was New World. I was playing New World Aeternum, but when the puppy came in, that had to switch, no pun intended, to the Nintendo Switch. Because I suddenly had a lot less, focused gaming time. So on the Switch, I've been checking out Sky by that game company.
Yeah.
Really, really beautiful game. I mean, I was familiar with Flower and Journey, of course. But Sky is just another awesome hit and feels really unique in the gaming sphere. So been really, really enjoying that experience.
Yeah, Sky is amazing. And of course, the company started by Genova Chen, as you mentioned, it did Flower and Journey, not just incredible artists, but really makes very heartfelt, moving experiences. And Sky is certainly right up there with that as well. Love the game too. Very cool. Awesome. Adam, how about you, buddy?
I am right in the middle of a Baldur's Gate 3 playthrough. So I'm doing my first playthrough right now. I just finished Act 2 over the weekend. And when my daughter goes to sleep, I'm getting a couple hours here and there to keep advancing. That game is so much fun.
Yes.
Larian did a really good job with that game.
Yeah, they did. Brilliant game. And I'm not able to spend enough time playing it. So, I always wind up going, I haven't gotten that far. Let me restart. So I have to find some dedicated time. But too many games to play.
Ain't that the truth?
How about you, Serge?
So I've been playing FIFA, FC25 for the past few weeks. I'm going back to it, slowly getting ready for the World Cup, actually. That's why.
Oh, there you go. Very good.
To compete in the World Cup.
You never know.
There's still hope. There's still hope.
That's still hope.
Those skills all translate, right? Of course.
Of course, yeah.
Well, speaking of the Switch, I've been making my way back through Paper Mario: The Thousand-Year Door, the remake.
Ooh.
And my goodness, Nintendo just continues to knock it out of the park every time they bring one of these games back around. And it's an incredible game. If you've never played the original, definitely worth picking up. Well, even if you played the original, it's definitely worth picking up on the Switch, and it's absolutely lovely. But I've also been playing a Quest VR game called Starship Home. I don't know if you all have heard of this, but if there is any game that is really going to sell players on mixed reality games, this is the title that's going to do it. It basically turns whatever room you're in into a spaceship where you're placing windows and sealing, basically windows on the wall and control panels. And as you're hurtling through space, you can walk around the room and look out any window to see where you're traveling. It does holograms around the room. It does incredibly well with geometry detection in the room. So picking up a virtual planter and putting it on my physical desk in my office, and it's just hanging out there doing exactly what it's supposed to be doing. Oh my God, it is amazing. It's really amazing. I think, Meta has really gone ahead and set the bar really high for not just the quality of VR games and XR-based games, but the price point, right? So I think we're at that magic 80% ratio. When you're about 80% as good as the next biggest thing, that's the tipping point. So definitely go ahead and check it out if you have a VR headset. It's Starship Home. So good. Oh, my goodness. So
that sounds so cool.
Yeah,
You're telling me.
It surprised the hell out of me how good it is. So, so that's what we're playing. Awesome picks all. And why don't we go ahead and jump right in to discussing how using containers can assist developers in reducing costs over the life cycle of a game. And we're going to discuss the challenges that developers face today that they can overcome. So what are some of the common challenges for developers that they face in the typical game development life cycle?
Yeah, good question, Chris. I think that there are quite a lot of challenges that developers face. As I think everyone here can probably agree, making video games is really hard, but now making those video games free to play and also live service based can be even more challenging, right? And just if we take a look at the state of the games industry as a whole and some of the trends that we're seeing recently, I think that some of the biggest trends that we're seeing is increased costs, transition to those live service free-to-play games, and also game technology not meeting the demands of players, right? It's really tough because you need to constantly be developing and releasing things to have players coming back for more, right? You need to think about navigating a monetization strategy that doesn't alienate players. There are very high development costs and a lot of really intense competition that can make the game development lifecycle really challenging. And so I think that it's really important that we try to find ways to reduce the overhead of game development wherever we possibly can to make developing games easier, right? If you split a game up into 3 phases, let's say like game development or kind of planning, then there's production, launch, and post-launch. I think that there are really unique challenges where containers could help in each one of those phases, whether it's having to deal with inconsistent development environments, looking at play testing for QA or load testing, scaling game servers for a production, right? So I think that there are a lot of open questions that containers could possibly help solve.
Yeah, and I mean, it was going to be good to dig into that because when we think about containers, right, we're thinking about a structural way of going ahead and lumping either services or operational pieces together in these defined spaces that we can then connect a whole bunch of them together. But how does that really going to impact the traditional planning, pre-production, then the production environment, then deployment, and then the operational side, right, of games. Now, one of the things that you did mention that is, it bears repeating is, the move towards live ops services. And we think about live ops, right? It means a whole variety of different things. And a lot of times, developers, what they're trying to do is when they have a new project, they're building their dev pipeline and they're looking to get a vertical slice done, and they're kind of band-aiding things together because they need that to show to a publisher or to show to investors. And so a lot of times the networking side, the undifferentiated pieces that are becoming increasingly critical, right, for the long-term, the LTV, right, for the game and market, kind of gets pushed to the side. And later, when you try to go back and insert those technologies into this now, technical Gordian knot, right, of complexity, it becomes really problematic. And it's also why, from an industry perspective, we've seen ourselves repeat the same, and I shouldn't say bad, less informed architecture over time, sharding, right, servers, for example. And my friends that have been building those types of games for decades are like, well, that's what we knew how to do then, and we know how to operate it now, so we just keep making that same bad choice because we know how to operate that, right? There are better ways to do this, especially if you're starting from a sanitized development pipeline at the beginning. And, for all the things you talked about, rapid prototyping, inconsistent development environments, play testing for QA, really complex CI/CD integrations. How do you go ahead and operate open and closed beta testing, scaling of the servers? All of these things just really are the issues and considerations that face modern game development for game developers. It's a lot to manage. So the question is, right, how do game studios do all of this in a cost-effective manner?
Yeah, and I would just say, I think cost-effective is a really great thing to focus on because it's becoming incredibly cost-prohibitive to develop a game. So looking at every way we can reduce the costs to game development is key.
Yeah. And not to mention, like, we're talking about a single game, but a lot of studios now are kind of taking this approach of rapid iteration, not just on a single game, but doing new games, right? Saying like, oh, hey, we tried to find the fun. We couldn't find the fun with this, right? The vertical slice was a failure. On to the next project. We're not going to invest, years of our lives into this project where we don't see a future. So having that kind of repeatable infrastructure and repeatable process for building games, all the more important nowadays. Yeah. So enter
dun, 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 dun. Enter containers. So why don't we talk about what containers are? Adam, help us out here.
So a container is just a lightweight, like, portable environment. It's where we package up the application, all of its dependencies into a known good image, and then we can deploy that image across like a vast amount of different like infrastructure between AWS and third-party partners. And the big thing about containers is you get that consistent deployment. So like once it's packaged up, we've done our testing on it, we verified that everything works. You can take that container image and then deploy it wherever it's needed, and then you get very quickly like reproducible events that happen at that point, and you don't have to worry about like the constant like checking of resources to make sure it's actually running because we've already done the testing up front. Everything's packaged together. It can run in all these different environments, and we shouldn't run into any problems with it.
And when we talk about the scalability of containers, right, based on needs, can you speak to that?
Yeah. So the nice thing about containers is you can run as many as you want, or you can run as little as you want, right? And they can be very easily scaled up or down depending on where you're running them, right? So you can very quickly go from like 10 containers that are running an application, a game server, a backend service, to 20, to 30, to 50, to 60, all the way up to meet the demand that you're seeing on that particular service, right? And a lot of times, depending on the infrastructure that you've deployed that container service, game server, like what have you, like where you've deployed it, you can define the metrics on which it's scaling, right? And that granularity kind of helps with costs too, because we can do like just-in-time deployments of containers. We can keep costs low by spinning like services down, like during like lulls in usage, and we can spin them up right back to like higher quantities when we're having a lot of traffic.
Right, and that's very similar. If a game developer is experienced with something like GameLift, for example, right? In concept, a very similar type of cost and benefit in using a service like that, which can identify resources, spin those up as needed, then drop them off basically or shut them down when a game session is done. So you're only paying for the time that your players are actually playing on that server versus having to go ahead and co-locate a whole bunch of hardware, and hopefully you have your regions correctly. Hopefully you've got the scaling correct there, except that now we can put all of that application into a container, and that can move as a full verticalized stack solution to a global cloud infrastructure, correct?
Yep. You can deploy those in as many regions as you want to. You can deploy multiple containers onto like a single like instance of like a piece of hardware, like an EC2 instance. You can run multiple containers like at the same time on a singular instance, and that just scales out, right? So instead of having all these single points of failure, we have these artifacts in place where like if one unexpectedly quits or like has an issue, like we can tear that down and quickly spin up a new one.
Okay, so if a container accidentally quits, right? There was just something that happened in the infrastructure in which it's running. It's then able to go ahead and reconnect those connections to that container into a new container. We can provision for that.
You can provision. That really depends on state management, right? So if you're trying to reconnect like sessions like back to like a game server, right? So say like that entire server just died, right? You would need to maintain the state of the players that were connected to it. You could then spin up a new one. And then if your, backend logic, client logic for the engine you're using, or just the tooling that you've built for the backend allows you to, you could like reconnect them to like a new game server like that way.
And so, and if you have set up your backend to do this, then basically a container has all of the operational components, right? All the software, everything, the operating environment, all in a single container, instead of having to try to reconstitute that same stack from just raw primitives that are out there. So it saves you time. It allows you to go ahead and create those backup instances or backup containers, right? That can be launched immediately to handle those types of spillover or failure, right?
Yep. It's about being loosely coupled, and that's what like container services enable you to do, right? So instead of having like an entire stack like on a singular instance, we can spread that out across like multiple services that are doing very specific jobs, right? So if the game's like a game server container goes down, that's fine because our matchmaking service isn't tied to it. Our state management service like isn't tied to it. Like those can all be like separate container deployments on themselves. And so what we get is this very like loosely coupled service architecture so that if like one thing goes down, it doesn't take down like the entire experience for your players.
Very cool. Does anybody want to jump in here and talk about like where we've seen containers being used in game studios?
Yeah, I mean, I think we're talking about it a bit in the context of production, right? Like you've got a game up and running, you've got containers as say your game servers, which is a great example of where companies are using containers. And you mentioned GameLift, Chris, which is really interesting because we just announced that we're supporting containers on GameLift now. So you can have your cake and eat it too. Totally not a subtle plug by our esteemed Chris here. But that's definitely one place, but it doesn't just have to be game servers, and it also doesn't just have to be in production. I'd be really curious to hear from the rest of the team where containers actually help in the development phase of the game development lifecycle, because I think that the processes that surround building containers is actually one of the most powerful things about them. Not the technology itself, but actually the processes that are kind of implemented alongside them. Yes, I'm talking about DevOps.
That's a good point, Don. Definitely. I mean, they are portable, right? So you can definitely build a container locally on your workstation and start testing either your game backend service or your game server locally. Making sure also that you have enough CPU and memory to do that on your local workstation, but it gives you that ability. And once you are happy with the results, once you are very happy with the way the container behaves, you can then move it to your CI/CD pipeline and start pushing to another testing environment where you will do more integration testing and load testing, right? And then kick off that DevOps workflow that you just spoke about.
Yeah, I mean, when we're talking about that workflow, when we talk about the type of services that can be used here, can you all elaborate on the variety of AWS services that can be used in these containers for this development environment?
So you can use a wide variety of services, right? So we can use the Elastic Kubernetes service, which is EKS. So that is a Kubernetes control plane that runs on AWS, and you can deploy your containers there. We have our own Elastic Container Service, where you can just run Docker containers, like on either managed nodes or unmanaged, like EC2 instances. You can deploy them to like bare metal EC2 instances. You can deploy them to AWS Lambda. You can use GameLift, like Dom just said. And then if you're using them with like either of the container services, EKS or ECS, you have a serverless option called Fargate, where we manage the compute infrastructure for you, and you just focus on like, you know, you just focus on like the container and the application itself at that point, right? The only thing you have to tell the Fargate service basically is just how much memory and like cut of a CPU it needs, and then it's able to just scale out and deploy those containers as needed.
And it's also important to remember that when you say Fargate, you don't think Stargate, because every time you say Fargate, that is the first thing that pops in my head is Stargate. But it's not that. It's the other one. It's Fargate. But yeah, I mean, but in all seriousness, you know, having access to all of these services really lets you create a malleable, or it helps to establish a malleable environment in which you can provision these containers and launch them and leverage these other servers that allow for scalability, that allow for fault tolerance, that allow for a variety of different container integrations or container types into a single backend solution, right?
Yep. And another thing too is when you're using like the compute services, like with containers, we have options to run ARM workloads with our Graviton instances, and those help save costs dramatically while improving performance.
Absolutely.
So if you can architect either your game or your backend services to run on ARM, and you don't have any like dependencies that require like x86 architecture, it drastically improves the performance while reducing the cost too.
Yeah, and that's awesome, right? So if you're not familiar with the Graviton servers that we operate, definitely go ahead and check out. We'll make sure that all the links to everything we're talking about are in the show notes below. But to Adam's point, you now have the ability to go ahead and leverage different types of compute instances or units based on your needs, based on performance, based on location, based on cost, and yeah, using, you know, our Graviton services, our spot instances for certain workloads can dramatically decrease the cost while still maintaining the performance that you would expect or require. So really, really awesome. More options to create, right, these global games and this global infrastructure for operating those games. It's pretty amazing. And I mean, we talk about controlling the number of instances on the back end, like, do we have theoretical limits around these things? Can you talk a bit about how we control those instances, or how we have multi-tenancy for those backend services?
So that really just depends on like the service that you're using to run the containers. Like to use Kubernetes and EKS as an example, right? For multi-tenancy, like you can run like multiple games or backend services like in a singular EKS cluster on separate nodes. We would just separate those out via tags or labels, right? And it would say, hey, this specific service goes to these nodes with this specific tag. This game server goes to this specific node with this tag. So you can run them in all one like singular cluster at that point if you wanted to. A couple other things, like just to go along with that. I just lost my train of thought, guys. I'm sorry. Serge, back me up here.
Yeah, I mean, you were on the, talking about node labeling, right? Node groups, maybe also building some node groups, which are essentially tailored to the type of workloads that you will need to run on those node groups. And here you can actually think about a pool of EC2 instances that will serve a specific purpose. So it could be either running your game servers or your game services. They will be not isolated in per se, but they would actually help you moving those workloads to the right place, to the right node pools or node groups. And you can leverage that as a scaling mechanism as well, where you scale them independently from each other.
Yeah, one of the problems that I've seen containers help solve is the whole idea of like ownership and cost attribution within game backends, right? A lot of times when publishers have a game services backend, they want to be able to understand which of their games is consuming how much of infrastructure and resource, like what that's costing them, right? So that they can do that math of the ROI on the games and all of that stuff that isn't visible to the end player, but is really important for the business. And containers and container technologies are a great way of separating that out, because otherwise, multi-tenancy can get really hard to track, like exactly, who is paying for what.
Yeah, absolutely. And it can also surface efficiencies or optimization that one team may be utilizing in their container, their stack, that then can be operationalized across the company. As big publishers are looking to centralize a lot of technology, centralize a lot of that knowledge, right? Because as I mentioned right at the jump, that game development is, we have to get this thing done. So by hook or by crook, we're just going to grab what we know. We're going to make this thing work, and then we'll go back and fix it. It's almost like in the film production space. We'll fix it in post. No, you can't fix this in post. If it's not architected correctly from the beginning, you can have runaway costs that absolutely skyrocket, that you may not understand exactly why something is either breaking or operations are running away or services are not shutting down. So this also lets you experiment with different types of builds in a single environment to understand how to go ahead and create those efficiencies, right? So I imagine this also provides the ability to do the equivalent of like A/B testing of certain services or operational side of these things for your game that may be in alpha or in beta, right? So a lot of advantages to standing up that tech stack inside of a container that runs on common infrastructure, right?
And deciding on what technology you're going to use and standardizing on that and making your developers all use that same technology, because like Chris mentioned, when you don't do that and you're just focused on keeping your game, alive and successful and optimizing player experience, you can accumulate all of this massive tech debt, which is something that we've seen a lot of games customers dealing with on AWS today. And it becomes a really big pain, especially when you talk about things like cloud governance. And so containers is a really good starting point to standardize on before, you get to that point, so you can avoid those problems.
Yeah. I mean, a lot of what we're discussing right now is really around operational excellence, right? So Serge, can you walk us through, some of the considerations or things we think about when we think about operational excellence in this type of an environment?
Sure, Chris. There are many aspects. The first thing is definitely be able to try out the game servers or the game backends on different types of infrastructure. So let's say EC2 instance types or different types of containers runtime. So it could be ECS or EKS. So with the same container, we can try different flavors of containers runtimes. We can try different sizes of instances, find the right one that will work for the game, and then make it official. Like Gena just said, standardize it and make it like the standard for the team going forward. But another one, which is like the one for us, is security. So developers can actually scan locally on the workstation using CLIs that will allow them to run a quick check of the container, but they can also take advantage of some of the services that we have either on AWS or other platforms to scan the containers and find vulnerabilities. And I think for me, this is probably one of the most powerful aspects of containers, because they are a smaller footprint compared to a server. They're light. It's easy to add security checks in the game pipelines and say, please don't push anything to production. If I have a major security flow, I want my players to be happy. So mitigating security risks, is also a key factor. And interesting enough, I find containers ideal for DDoS. And it could sound counterintuitive, but when you run them on an EC2 instance, if you actually DDoS a game server or let's say a game backend that is containerized, you're actually just killing the container, and then the instance itself will still live, right, and can spin up another one. So the only thing you're doing is tracing the node, the EC2 instance, but because you have your memory and limit sets for the container, you can actually constrain the attackers to a very much smaller footprint and lowering your blast radius.
Wow, I've never thought about that, Serge. That's so cool.
Neither have I. I was
Yeah.
like, wait, that actually makes a lot of sense.
Exactly what's going through my head too. It's like, yeah, you are basically making your threat profile really, really small. So if somebody does attack, it doesn't compromise any of the other instances that are up and running or the other containers up and running. So you may have minimal impact for the players that may be connected to that one particular instance, or that container is doing a certain set of operations that you can then go ahead and fail over to another container with a different address and maybe, right? And
Exactly.
really mitigate things like DDoS attacks.
Yeah. Taking advantage of the self-healing capabilities of containers, especially when they run on platforms like Kubernetes, where they would respawn automatically based on your states.
Yeah.
Adam spoke about the state management earlier at the beginning. I think also Dom mentioned that. So you can actually say, I want to have 200 instances of my game servers running at any time. If one goes down, it gets replaced automatically. And then when you go into that mode, you can actually start thinking about GitOps. Which is, also something that Don just mentioned when he was talking about DevOps and all those strategies. So you can think about your live operations and how you want your games to be updated, how you want to run your patches. You have a much smaller footprint actually to update every time. You will never have to update the entire game. You just have to change containers and swap them. So that's also ideal, gives you more precision and focus on your changes, and then you make your player happy. You're not breaking the game every time you're doing an update.
Right. So by utilizing containers, you really are providing a flexible way to define those different pipelines, different components of the game, and you can assign different levels of compute and resources to something that may be more process intensive or throughput intensive versus others that may not be as latency sensitive or things of that nature. And so it really allows you to construct this modular backend based on those individual components for a backend, correct?
Yeah. And the small footprint means that you can be better right-sized to the demand, right? Compared to something that's less granular, like a big instance, right? If you have some big machine, you can't be as close to the curve, your demand curve, as containers do. So that's another way that containers help you to optimize costs, is to really only deploy as much as you need and not a ton extra.
Yeah, which is one of the things that can actually crater a company. It can crater a developer. And we've actually seen that right in the games industry over many years of not sizing this stuff correctly, thinking there was going to be a bigger launch than they did, or not anticipating launch issues like getting in on day one, right? To be able to actually start playing those games. Then you have massive attrition. Now you're left with this backend that can't be, those resources can't be repurposed to alleviate those problems. You're kind of stuck. And we've seen companies actually just fall over weeks into deployment after spending years building this game because they didn't size it correctly, they couldn't scale correctly, they didn't have their costs contained. And so really, really important to build it as flexibly as possible to go ahead and meet whatever vector of demand your players are going to place on your game and your service.
And that segues into a question that I have about load testing. So, Serge, you mentioned using containers for load testing. I'm wondering if you or Adam could talk a little bit about how you can do that and, the benefit of load testing, because just from my experience, a trend that I'm seeing is more and more customers thinking about load testing so that, they can appropriately scale their infrastructure for game launches.
So
Go ahead, Serge.
Go ahead.
Go ahead. Okay.
I think we're on the same train of thought.
I'll speak to the benefits, and Serge can speak about the how-to. We're working on a lot of stuff together, like on this, like right now. But the benefit of load testing is basically like kind of like twofold, right? Is one, we get to see how the game interacts with backend services like in a live environment, right? You can test locally, you can test in like small like private environments and everything, but like once you have it live and you're connecting to stuff like over the open internet and everything, we know that like behavior can change and things can happen, right? So when you get to see how that game is interacting with the backend service. The other thing too is it helps us identify like bottlenecks like in the services, right? So we can see things where like maybe database queries aren't optimized for requests that like the game servers are running to like a state management or a player database that's like holding like their inventory, right? For like what they're doing. And another thing is it helps us identify like service quotas, like for our services that we need to raise, right? So if we run, if we have an expected CCU count or player like count of like 50,000, say, hey, when we launch this game, we think 50,000 players are going to play it on day one. Well, if we load test up to 100K or 200K players at that point, and we see that we don't have any issues, we haven't run any service quotas, we know that we can handle that 50K amount of player traffic like without really any issues. We just need to do like our normal monitoring process at that point. But if we see we're breaking in that test at 50K or 60K or 70K, at that point, when we say, okay, cool, we can go back and adjust these service quotas with our support organization. And at that point, we should be able to scale past that without any issues. Serge, you want to talk about how you would do that?
Yeah, the how is the interesting part. So what is challenging with load testing is that you need to scale your test clients, and you have to test them against the real version of your architecture. So it could be your game servers, your game backends. To actually scale your clients, it's quite interesting. You can use containers actually for that. You can take your test code, containerize it, so package it as a container, and run it from, let's say, a Kubernetes cluster or an EC2 instance, and just say, please go up to a certain number of clients, and then send your traffic to a specific endpoint. Now you are sending suddenly load to your server side, game servers or backend, and you have control on your client side because you are using containers to do that. And if you want to test from multiple regions, then you just need to copy that infrastructure across different regions, right? So moving your EKS cluster to US East to US West, and then just sending traffic over to your game and your game server. When you're doing that, you also have the ability to use native functions on the containers runtime to mimic the patterns of your traffic. So you could essentially say, please schedule containers to run every X minutes, and then it will actually simulate, let's say your traffic shaping for your game. Or you can actually also do other things like, okay, I'm running my load test, but I also want to see what happens if I have a sudden interruption of all the traffic altogether when my server is already under stress. So it gives you also a little bit of entry point to chaos engineering and fault injection.
I could listen to Serge talk about this for like hours. This is actual gold coming out here.
That's a lot of long nights deploying containers, actually.
Right. Which is why, if you're listening to this, don't spend those long nights. Lean on the expertise and the work that our senior solutions architects have already done, right, in testing these things, understanding how to put these together. And, one of the things that I think is important to bring up is, as we're sitting here talking about this, it really dawns on me just how incredibly powerful and flexible building a containerized, or taking that containerized approach to backends can be. But it's also can be really complex because there's so many different ways to go ahead and structure these things. So if somebody is new to using containers, what would be your recommended first steps? What would you say are the top 2 or 3 things that they should consider using a container for as they're starting to develop their game from the beginning?
I can go first since I probably have kind of more of a fun answer. I'm going to steal something that Dominic worked on a couple of years ago, actually, which if you're looking at, getting hands-on and you're a better learner when you actually like jump in and build something, you can set up a Minecraft server using containers, right? And then that way, now you've learned how to set up your first container, and you've also got a really fun Minecraft server that you and your friends can play on. So That's probably not the answer you're looking for, Chris.
No, actually, let me tell you, I think that is a really wonderful answer. And one of the things that we talk about in a variety of the different programming that we do here at AWS for Games is, especially when I go back and I look at the history of games, so many of us got started in the industry just by standing up a little game or trying to learn these tools by making a game. Because if we can use fun as the motivator to have you learn these things, then it becomes a whole lot easier. I think it is absolutely a wonderful piece of advice for anybody just getting started with containers. I love that. And I have to say, of course, Minecraft being one of the biggest games in the world and was written entirely in Java, of course, my Java background comes flying back through. I can't let that go. So, great advice, Gena. How about you, Dominic?
Oh man, that is great advice, and it feels like dredging up the past. But
by the way, and you're also like, and what a wonderful example to use, the one that I created.
Yeah, right. I appreciate the shout out, but
that's why I wanted to go first.
It rings so true because I learned about ports from like port forwarding games so that like me and my friends could play multiplayer games together. And I was like, what the heck is going on? Why can't they join my game? And like learning about port forward, it's such a good example of like how to get started. Okay, I don't know if I can follow that up, but I did promise at the beginning of the show that I brought in my favorite containers.
Let me see your favorite container.
Dun, 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 here it is. It is a Tupperware container. I use these things all the time. But there is actually a point here, and it's something that we've been saying all show, that containers are lightweight and portable. You get it? And the thing that I want, thank you, Chris. I do not deserve that. The thing that I want listeners to think about when thinking about where they should think about using containers in their infrastructure for their games is the flexibility that it will allow you, right? I'll give you an example. Say that you're a company that's still mostly on-prem and you're just beginning your cloud journey. Containers are still going to be helpful and a good idea for you because it allows you to have the agility and flexibility. We talk about this a lot at AWS to experiment, right? And it's going to allow you to bring projects that would take like months or even years down to weeks or even days, because you can deploy this wherever. You can put this wherever, right? You take your leftovers, you put it in the fridge, and it works there. Or you can put it in your lunchbox and take it to work. It works there too. So maybe a bit of a stretched analogy, but that's what I think it should be the first thing in your mind when you're thinking about where to deploy containers is where do you want the most flexibility? If you run game servers on-prem right now, maybe containers are the first step to allow you to run those in the cloud and therefore anywhere you want in the world.
I think a really important distinction that we need to make, though, is you cannot store leftovers in containers on AWS.
Right. Exactly. That's a good point. Yes, you cannot do
Just
that.
to
Yes.
be clear.
Oh, no.
Just the smell of that container after 2 weeks sitting there in a hot data center, right? That would be terrible. But actually, you also bring up a really good thought as well, which is by experimenting with those containers, you can go ahead and do things with a particular service that if it breaks, you don't have to worry about the rest of everything breaking as well, right? And so it does provide a really flexible environment for experimentation and optimization and learning as you go. Really great advice. All right, Adam, how about you, buddy?
I think for me, if it's like you're just getting started with containers, like test locally first and just have a lot of fun with it, right? Like build a Minecraft server, like build, like a quick proxy for like UDP hosting. Like look at open source solutions that can like help like speed up your learning and deployment of those things. And then always just kind of remember that containers are meant to be torn down, right? So they're not fixed points in space and time. Like they are meant to come and go as needed. And so you should be really using that to like do rapid prototyping and iteration, right? And just constantly working to improve it. And then the big thing is like, once you're ready to like step foot like into the cloud and start deploying stuff there, like look at the serverless implementations like Fargate, because it makes those like first few times that you're deploying something like very, very easy comparatively, because you're not managing like the underlying infrastructure that goes with it. So it's just that, like, test locally, have fun with it. Just remember that it's for rapid prototyping, and you can tear them down at any time and restart them if you need to make an update or fix something. And then look at the serverless tech, because it makes those first few deployments really easy as you're learning all the different services you have access to on AWS.
Yeah, again, really fantastic advice. Awesome. All right, Serge, last thoughts?
Last thought. Okay. All right. So there are a couple of interesting things also on the culture side and the mindset, right? So if you're coming from the server world, there are no racks, no cables, no storage to plug. I remember those long nights just shuffling servers in a data center. So you have to think about it that way as well, that you are not going to touch any physical infrastructure for this, at least. It's all virtual. And once you shift your mindset toward that and you understand that the footprint is different, I really love what Adam said about be able to experiment. And for me, the way to go is just take the Docker command line and start playing. Go to Docker Hub, look at a few Docker images. Actually, there might be a Minecraft one.
There is one. I didn't set that up myself. I just stole the one that already existed.
Exactly, like a Java-based Minecraft server, Dockerized. That's powerful. And just run it, play with it, learn how to expose the parse, run volumes. And once you're ready, there's a lot of things in the open source world, actually, that you could leverage for your next journey. So that would be my go-to.
Again, just really wonderful advice, excellent advice and guidance from all of my co-hosts here today. And I want to thank my co-hosts with me here today on Boss Level. If you have any topic requests for future episodes, make sure you drop them in the comments below. Also, make sure that you like, subscribe, and hit the alert so you know when new episodes of Boss Level are released. And we would like to thank you all for hanging out with us today, and more to come on Boss Level. Thanks, gang. Appreciate you all.
Thanks, everybody.
Thanks, Chris.
Thank
Cheers.
you. Cheers.